go ahead and tell me what you've done so far
So,
and then how you finish it.
okay, what I did is, so I took the tin, I dipped it in this flux,
Uh-huh.
and then used the soldering iron to melt that onto the clip.
Uh-huh. And that's called tinning.
Tinning, yes. And then now I'm about to take the wire that I'm going to attach to it. I'm going to dip that in the flux too, and then melt that onto there to make it stick.
Nice.
With the, so that it stays there. And then I'm going to take some more of the tin, dip that in the flux, and then melt some of that on there.
Nice. Make sure that you hold the soldering iron on the metal itself so that it all gets nice and hot all the way through.
Okay.
There you go.
And keep it there till it hardens.
Nice. Cool. Then how do you know if it's a hot solder joint? How do you know if it got hot enough?
If it got hot enough, it's not gonna beat up and it's gonna be glossy and smooth over it.
Nice. Nice. I'm going to show you the difference between DC and AC current flow using this visual simulator. Here I'll turn both circuits on so you can see the behavior of the circuits, and then I will discuss further by turning on the visualization of the electrons flowing through the circuit. See here on the DC side, it is flowing one direction. The electrons are flowing one direction through the loop in a direct current flow. So that's why it's called DC, or direct current. On the AC side, see how it pulsates? It goes back and forth. First one direction around and then reverses and goes the other direction. So it's a constant back and forth shuffle of the electrons. Here you see both side by side comparison. On the AC side, see how the light bulb is actually flashing on and off? That actually happens 60 times a second, or 60 hertz as we call it, in United States, and 50 hertz elsewhere. It's so fast that our eyes don't detect that flashing. The easiest way to troubleshoot a circuit is to look for voltage. So look for the farthest voltage you can get away from the battery on your way from positive to negative. I have this sample circuit laid out, so I'm going to go ahead and connect it. And so basically it's a very simple circuit. It's just comprised of the battery, 12-volt battery, a 12-volt light bulb, a switch that controls it, and a fuse. It should work. If I flip the switch, it should turn the light bulb on, but it's not turning the light bulb on. So what's wrong? Okay, let's find it. Let's find the problem. So the way you do that is connect your negative test lead to ground, to the negative of the battery. In a car, you could connect to, because the negative terminal of the battery is connected to the body of the vehicle, you could connect the negative probe of your tester to any clean metal object on the car that is very clearly connected to the car frame. And you can actually use the ohm setting at 200. You can use that, and you can test to see, like, this body of the light socket is connected to this this wire that goes to negative. So I could connect to see if it's a good ground point for me to use as a reference. I can use that ohms check function, and there, see, I'm getting 0.5, 0.4. So that's a good, quote unquote zero. It's saying that there's good continuity or good connection between this point and the negative terminal of the battery. So even if that was a more convenient place for me to reach with my test lead, I could connect it there, and that would be still a good ground reference point. So anyway, getting back to our troubleshooting example, we have it set to 20 volts, so we're looking for a 12 volt signal, or as much voltage as we can get of that 12 volts. And what we do is just we connect the negative terminal or test lead to ground, and then we just keep testing along the system and seeing where we find voltage. I can't quite read it on the outside, so if I take the light bulb out and put see that pin down in there, that point should be the positive coming from the positive terminal of the battery. That should be where the positive terminal of the light bulb gets its power. So if I put my test probe there, I get 0. So there's no voltage getting from here to here. So that's the farthest out, that's the closest to my return path to the battery. I'm not getting 12 volts there, so I better move further down the line to see if I get 12 volts somewhere else. Let's see if I get 12 volts at the connection after the switch. So this is the power goes into the switch and then comes out of the switch. Let's see if I'm getting power out of the switch when the switch is flipped in the on position. There's 0, no power there. Let's see if I'm getting power going into the switch. I'll test right there. Nope, nothing. So keep following back. Oh, here's the fuse. I wonder if the fuse is blown. Let me test on the outbound part of the fuse. And there I have, it says 8 volts. So it looks like there's kind of a connection in there. I'm going to shake that around a little bit to see if it's just a fluky connection in there. So it says I have about 7 volts. I'm going to test on this side. There I have 13 volts, which is battery voltage. 13.14, 13.14. So I have full battery voltage here. I have a tiny bit of battery voltage here, which is actually curious. I think there must be just a trace of that wire, the connection still left in that fuse. In other words, this is a blown fuse. It's randomly letting a little bit of power through because I think the wire is kind of loose and rattling around in there. So I'm getting a tiny bit of power out, but not enough to light this bulb. Okay, I found that the fuse is the problem. Okay, what if I replace that fuse with a new fuse? Let's see if that fixes our problem. I'm going to turn the switch off, connect the new fuse, now turn the switch back on. Bingo! There we go. And now you see there's battery voltage there, and it's under load, so it's going to be slightly less than the open circuit voltage of the battery, 13.12 or whatever it was. So there's full battery voltage. And then I see voltage going into the switch, voltage coming out of the switch. If I take the light bulb out, I'm measuring battery voltage at that point where I was not getting it previously. So that's a good way to test, to troubleshoot a circuit. Connect your negative lead of the multimeter to that ground reference, and then just test. Go as far away from the positive as you can and just work your way back until you find the problem.